The most common storm is the thunderstorm. At any one time, there may be as many as 1,800 thunderstorms occurring at different places on Earth.
In North America, thunderstorms are frequently experienced in the central and southern regions of the United States. The typical thunderstorm cloud, the cumulonimbus, or thunderhead, develops like many clouds when warm air rises from the surface of the Earth. As the warm air rises, it cools, and water vapor condenses into minute cloud droplets.
In a thunderstorm, the updraft of warm air is rapid. The cloud builds quickly, often attaining heights of several kilometers in a matter of minutes.
As the thunderhead grows to maturity, water and ice droplets come together.
Precipitation begins. The onset of a thunderstorm almost always includes strong gusts of wind and heavy rain.
Some violent thunderstorms can also produce hail, pellets of ice that can descend in torrential showers and cause millions of dollars in property damage every year.
But the most dangerous and spectacular of all thunderstorm features is lightning.
Lightning is a burst of electrical energy that flows between regions of opposite electrical charge associated with thunderstorm activity.
Usually, lightning strikes between two different parts of a cloud. But often, it strikes between a cloud and Earth.
Charges on Earth tend to be induced on high or pointed objects before lightning strikes. This is why it is advisable to avoid being near these objects during a thunderstorm.
In the aftermath of some thunderstorms, flash flooding presents yet another danger to life and property. In most cases, the destruction caused by the passing thunderstorm is slight. Its dangers can be avoided through minimal precaution. But occasionally, the thunderstorm cloud produces an offspring that is a major storm in its own right, the tornado.
Tornadoes have been observed in many parts of the world, but they are most frequently observed in the southern and central regions of the United States. Tornado season comes to this area in the early spring, when energy-laden masses of warm, moist air from the tropics meet with cool, drier air from the north or west. The storms that sometimes result, with winds rotating at an estimated 500 kilometers per hour, comprise one of nature's most violent and terrifying phenomena. No storm expends a greater amount of energy in so small a space. Each year, these storms claim scores of lives and millions of dollars in property damage. This machine, located in a meteorology laboratory at the University of Chicago, produces a miniature tornado whirlwind. Slow-motion photography and tracers generated with the help of dry ice enable meteorologists to study the counterclockwise spiral that is characteristic of tornadoes in the northern hemisphere. Research has shown that the structure of the tornado funnel is complex. In general, wind speed is greatest around the core of the funnel. Pressure is lowest in the core itself. As this laboratory simulation demonstrates, the tornado's low pressure within the vortex
can cause the walls and roof of a building to explode outward under the force of the higher pressure inside.
This is why it is recommended that windows, away from the tornado's approach, be kept open.
Because of the tornado's enormous destructive potential, meteorologists give high priority to prediction and warning methods.
They have learned that tornadoes are likely to occur when cool, dry air clashes with warm, humid air under unstable atmospheric conditions.
We have this very moist air flowing northward. At the same time, we have cool air pushing down across Kansas, and a movement of quite dry air coming in here. They will all be clashing. Circumstances are very good for severe weather to break out.
When these atmospheric conditions are present, the National Weather Service issues a tornado watch to the public. A tornado watch generally covers a relatively large area and indicates the time period over which tornadoes are likely to occur.
During the alert, meteorologists use radar to scan the atmosphere for the characteristic hooked cloud that may signify a tornado formation.
If an actual storm is sighted, either by direct observation or by radar, a tornado warning is issued by all available means.
Roger, Troop A. This is the National Weather Service radar room. We've issued a tornado warning that will be in effect until 4 p.m. for persons in Jackson and Clay counties in Missouri. The tornado was sighted 15 miles southwest or 230 degrees from downtown Kansas City. At 3 p.m., the tornado was moving towards the northeast at 25 miles an hour.
A tornado warning specifies the location at which the storm was sighted and the areas likely to be affected.
Following received from Oklahoma City, Oklahoma. Tornado touchdown 10 miles southwest of Oklahoma City, Oklahoma at 12:45 p.m. Central Standard Time. Tornado is moving northeastward at 15 miles an hour.
Immediate precautions are necessary because the tornado is erratic and unpredictable.
Even though it is a brief local storm, its consequences can be disastrous.